Assalamu alaikum. Welcome to the presentation. In this presentation, we will talk about some string matching algorithm. At first, I would like to thanks to our honorable mentor, that is MD Ohidur Rahman, Assistant Professor, Institute of Information Technology, Noakhali Science and Technology University. Algorithm is the best solution way for any kind of problem, and string matching, if we want to know about to how to solve some string matching problem, then uh, we have to know about some string matching algorithm. So how can we know about the string matching algorithm? First of all, we have to know that what is string matching algorithm is, and then we will discuss in this presentation about some algorithm classification, and at last we will know about application of string matching algorithm. So after the presentation, you will have a great idea about string match, how to solve a string matching problem efficiently. So what is string matching algorithm? String matching algorithm is like if we have two strings, we have to just check that if two strings are matching or mismatching. And it string matching algorithms have greatly influenced in computer science and play an essential role in various real world problems. So these algorithms are useful in the case of searching a string with another string, and string matching is also used in database network systems. So the algorithm classification is like there are two types of string matching algorithms. At first type, we will know about some exact string matching algorithm. These types are like naive algorithm, of KMP algorithm, and Rabin Crab algorithm. And then the approximate string matching algorithm, it's also have the naive approach. Then the Seller's algorithm, it's based on dynamic programming, and the shift or algorithm, that is based on bitmap algorithm. So the exact naive approach means that it's a brute force approach ever, and here just it's the simplest way to check if the two strings are matching or mismatching. It's just slides the pattern over text one by one and check for match. If a match found, then slides by one, and again check if any other subsequents are matching or not. So exact naive approach pseudocode is like a brute force solution, and this is not so any complex solution. Which I think first just have the length of two strings, and then we have to check every character by through two loops. If there are not any mismatch, we will break the loop. So here the worst case complexity would be like order of n square, and the best case would be like order of 1. Then the exact KMP algorithm. If we want to know about the KMP algorithm, it's very efficient algorithm for matching two strings. The idea is whenever a mismatch is detected, we already know some characters in the text of the next window. So we take the advantage of this information to avoid matching the character that we know will anyway match. So if we have a look about the pseudocode of KMP algorithm, here just first of all we calculate the maximum longest suffix length and hold it, and then we just check that if the longest subsequence of pattern are matching with the text or not. If matching, then we will stated it as the matched string part, and then check for another subsequence. That's it. So the KMP algorithm uses degenerating property and appearing more than once in the pattern. We already discussed about this, and this pattern are searching so efficiently that this complexity are which we are see that in naive approach there the odds case are going to the about order of n square, but here the odds case complexity is to order of n. So that is so efficient way to search if there have any match or if there have any match in two strings or not. So then the exact Rabin Crab algorithm, it actually matches the hash value of the pattern with the hash value of the kind substring of text. If the hash value match, then only it start matching individual characters, otherwise not. So if the pattern hash with the pattern hash value and the text hash value have will match, then it will check that which character are matching. Without these conditions having make true, the checking will be not checking you start will not occurs actually. So exact Rabin curve algorithm is like if we see the pseudocode of this, uh, here we are doing some dynamic programming approach to get the hash to get the best move ever. And if pattern if we have any matching item with the pattern hash value and string hash value, then we can see that we can say that there will have any subsequence that has matched item, then we'll check it, otherwise not. So here the average and best case running time of the Rabin curve algorithm is like order of n plus m, and the worst case will be the order of nm. So nm means the n is the length of the text length and m is the length of pattern length. So if it's depend on the both, because if the pattern length hash value here we have to get the hash value of pattern, and we have to get the hash value of text also. And after the matched item of in the hash item, then we will then we'll see that if there has any match, which item are matching or which item are not matching. The worst case of the Rabin curve algorithm occurs when all characters of pattern and text are the same as the hash values of all the substrings of text array match with the hash value of pattern array match. So here the last topics we have we will discuss about discuss to know about the string matching algorithm. Uh, Still till now we are discussing about the exact way, and now we will be discussed about the approximation string matching. In this process the naive approach, it's like the exact approach, it's the brute force type solutions, and it slides the pattern over text one by one and check for approximate matches. If they are found, then slides one again. It's like the exact naive approach. And then the Sailor's algorithm, algorithm is basically based on dynamic programming, and this improves the search technique better. And then the shifter algorithm, it's based on bitmap algorithm. So here the application is string matching. It has large apply sector, and these are really important. And the sectors are like, if we want to check plagiarism check in any kind of documentation, then we have to take the help of string matching algorithm. Then the DNA sequencing, then digital forensic, then the pair of spell checker, content search in large database, intrusion detection system. That's at the applicable sector. And if we see some applicable sector more precisely, uh, then we are seeing that how string matching helps in DNA sequencing. The DNA, first of all, we are getting the DNA data and the amino acid sequence. Then then we will match that with the DNA data and amino acid sequence. If there have any match, uh, we will get a result for this, and thus the DNA sequencing are working actually. So that's all from me. Hope you are uh, enjoyed the video and understand what I have described to yours. And last of all, I want to say that string matching algorithm is very important to us because in today's world, we are in many spheres. String matching uh, problems are arised, and these problems uh, are easily can solvable with string matching algorithm. So I think you should have a great knowledge in this topic. So if you have any further question about these topics, please inform me. Uh, that's all. Assalamu alaikum to all.